Cycle 1, you will have been taught the behaviors of the functions in Grade 12 Advanced Functions. Although you'll have an understanding of the functions and how they work, you won't necessarily be able to graph them algebraically on your own. Instead, you'll be dependent on Desmos to do that part for you. But here's where it gets interesting. What if you've been given a set of data points and you want to make a function that can almost perfectly display the data? Well, at this point, you can't do that using algebra. So how would you do that? Well, that's where regression can come in handy. So, what is regression? Well, regression by definition is a method for fitting a curve, not necessarily a straight line, through a set of points using some goodness of fit criteria. In other words, it is a way to create a curve of best fit for a given or made set of data points. It allows for representation for said function to display certain data points in a set scenario. In the end, regression is a way for us to figure out a curve of best fit with set of data on Desmos. Now that we have an understanding of what regression is, let's look at this example. Yusuf and Ahmed have recently started their own footwear store. Here are the sales in terms of shoes sold per day for the first 7 days. Day 1, they sold 19. Day 2, they sold 29. Day 3, they sold 44. Day 4, they sold 35. Day 5, they sold 32. Day 6, they sold 54. And day 7, they sold 49. So it asks us to create a table of values to display their sales below. So how do we create a table of values? Well, on Desmos, by going to the top left corner, we see this little plus sign, which says add item once we roll over it. Let's click on that. Third down, we can see it says table. So let's click on that. What this does is provides us with the x1, y1 table. In this, we can plug in our data. So in this case, the x-axis will represent the day number, and the y-axis will represent how many shoes were sold. So, as far as the days went, they had day 1 to day 7. So, for the x1, we can put in 1, click the down arrow key, 2, click down arrow key, 3, down arrow key, 4, 5, 6, and 7. Now let's move to the y values. So, under y1, we can plug in the first day sales, which was 19, the second day being 29, third day being 44, fourth day being 35, fifth day being 32, sixth day being 54, and seventh day being 49. So what this has done is plotted these data points onto our graph. To get a better understanding of the points, we can zoom in just a bit more. In order to zoom in, we go to the top right of our screen where it says zoom in with the plus sign. And we can just click on that once and it'll zoom in a bit more. There we go. So now it says, use regression of a quadratic, linear, and quartic function to find a curve of best fit. So how do we do this? Well, the way regression works is by using the base function of any function. So let's start with the easy one, linear. We know that the base function of a linear function is y equals mx plus b, where there are also transformations given. So in order to do a regression, we want to switch this equal sign with that little squiggly line that you can access by clicking on this ABC button on the bottom left of the keyboard, and then moving over to it as a second last option. Now you'll see that nothing has popped up yet, and this is because our data is actually x1 and y1, whereas our equation only represents y and x. So what we want to do is press 1 right after the y and 1 right after the x. And so we'll model each of those as x1 and y1. Once you do that, you'll see that the line has popped up. Now, if we take a look at the statistics given, we have r-squared value of 0.652. The r-squared value represents how well the function has modeled the data. In that case, 0 would be the worst and 1 is where it's perfect. So in this case, it was pretty mediocre with 0.652, which isn't that bad, but nor is it that good. If we look into the parameters, we get the m value and the b value for this given line. So if you want to create an equation using that, you just switch the m and b with these given values. So in this case, it would be y equals 4.6 with the rounded value of that, x plus 19.1 with the rounded value of that. Now the second thing it asks us is for a quadratic regression. So just as we did above, we want to start by writing down our base equation. for a quadratic equation. So that is y equals ax squared plus bx plus c. Again, nothing will be plotted because we haven't switched our equal sign with that squiggly line. So we want to just get rid of that equal sign, click the ABC button, keep going until we see that squiggly line, press it, and last but not least, change the y with the y1, change the x with the x1, and change the bx with the bx1. So right away you can see that it's plotted the new parabolic shape. And if we zoom out using our scrolling button, it also shows that. So we can see a better understanding of where the parabola has been modeled. And we can just zoom in again. Now, the advantage of plotting more than one function on the same graph is that we can get a better visual representation of which of those actually models the data best. So after doing that, we can also look at the x squared value. So for the quadratic formula, it had r squared value of 0.662, which was a little bit higher than the 0.652. So ideally, the parabola models this data a bit better. In this case, the a value of the parabola would be negative 0.3, the c value would be 15.14, and the b value would be 7.24 if we round the 8. The next thing we want to do is add the quartic function. So again, to add another function on the same graph, you just want to click right underneath the plotted point, and that'll give you another option. So let's put in our quartic function. So the quartic function's base function is y equals ax to the power of 4 plus bx to the power of 3 plus cx squared plus dx plus e. And again, to do the regression of this, we want to switch that equal sign with that squiggly line by clicking the ABC button in the bottom left of the keyboard, and then switching with the squiggly line, and changing the y value with y1, the x with the x1, the bx with the bx1, cx with the cx1, and the dx with the dx1. And right away we can see that a blue line has been plotted onto our data to model it. So now let's see how the statistics of this are. So the r squared value is quite a bit higher than the other ones, being at 0.718. That is a lot better than what we had before, so ideally it models the data a bit better. The a value in this case would have been negative 0.05 if we were to round it. The c value would be negative 7.6. The b value would be 1.04. The d value would be 25.6 if we were to round that. So that is basically how you do a regression. Now, it can be done for many more functions rather than just a linear, quadratic, and quartic function. You can do it with any function that you know the basic equation of with the transformations. So if we were to take this one step farther and just add a logarithmic function, for example, so let's put in our base logarithmic function, which is y equals a log, bracket k being the horizontal stretch or compression, bracket x minus d for the translation, plus c for the other translation. And then again, we want to switch the equal sign with the squiggly line, switch the y with the y1, and switch the x with a x1. It can plot that as well. Here, let's just remove our black line and the quadratic line as well, just to get a better visual representation. So, in this case, the log value would have been, the r squared value for the log function would have been 0.681, which still wasn't as good as the quartic. But if we were to evaluate the actual graph of it, it would make more sense. What you want to realize is that the r squared value only represents how well the line fits the given data points. But if we were to look at the past or the future of that scenario, it might not make sense. So in this case, the log function ideally would be a better way to represent this data, because if you look at the quartic function, it goes into negatives for the amount of days that they've sold the shoes for, which ideally doesn't make sense because you can't open a store in negative days. On the other hand, the log function does not go past the 0, which would make more sense. Not only that, but if you were to look in the future, it does not go into negative sales, which could be possible, but the way that this data is shown, there are no negative values. So if you were to predict the future of this company, it would not be too dull. And that is basically how you create a regression for a function. Again, you want to use the table of values, being given the data points. Then you want to choose your equations that you want to use, write the base equation down, switch the equal sign with a squiggly line, and then switch the y with the y1 and the x with the x1 to better represent the table of values. Again, whatever other function you're using, if you have another table of values, it could be a y2 or x2 or even a y3 or x3 and so on. So here's a quick recap of what I've taught you. First off, to perform a regression, you want to create a table of values using the plus sign at the top left of Desmos. Next, if you want to put multiple functions on the same graph, you want to simply click underneath the row or the column that you're using on the left side of your screen where you can write down the equations. Now to use regression, the first thing you want to do is put in the base function with any transformation variables for that equation. So if we were to use the linear, it'd be y equals mx plus b, or if you were to use a quadratic, it'd be y equals ax squared plus bx plus c, and so on. What you want to do then is insert the squiggly line instead of the equal sign by opening up the keyboard, clicking on the ABC button, and moving to the right, and you'd see it right next to the other buttons. And then you want to follow that with a subscript of 1, or whichever number that the table of values represents, under each x and y. Lastly, we talked about the r-squared value, which represents the accuracy of the curve, where 0 is horrible and 1 is perfect. Again, the r-squared value might not be the best representation, but it does do for the data points. And that is regression in advanced functions, grade 12 math.